Alright, in this video we are going to talk about multiplying a fraction by a fraction. It kind of goes in correlation with, with multiplying by a whole number. The only difference is you have two fractions now that you're working with. So let's look at some examples that we can work out and solve together. So let's say I have 1/3 times 1/5. All I have to do and remember is that I multiply straight across. I don't have to find a common denominator with multiplication. So 1 times 1 is 1, and 3 times 5 is 15. So it sounds easy, and it is easy. It's pretty simple. But it can be a little bit tricky when you have a word problem. So let's look at a word problem. I'm just going to kind of read one out loud and then kind of talk through how to solve it. So a small rug is half of a yard long. Okay, and it is 7/6 of a yard wide. I want to write and solve an expression or an equation to find the area of this rug. So if I have to draw it out, it's 1/2 times 7/6. So I know it's going to be 1/2 times 7/6. I know 7 times, and all I got to do is multiply across, both top and bottom. I don't have to find that common denominator. 1 times 7 is 7. 2 times 6 is 12ths. So I know that my rug is 7/12, or has an area of 7/12 square yards. Okay. Let's do another one. Once again, I'm just going to read this out loud and talk through it. So, say for example, I'm given a problem with a model already drawn for me. And it wants to know that Sally is asked to multiply two fractions, and she starts to model the problem but has not yet shaded. Which multiplication expressions could Sally be modeling? Well, just by looking at this, I can break it down into rows and columns. Okay, so she could be modeling several of these. But I want to start off by finding the denominator of my rows and the denominator of my columns, which is the total amount. So I'm going to look at my columns, and I'm going to say, okay, well, I have 3 columns, and I have 4 rows. And so that's a key telltale sign there. That's a possibility to give me endless possibilities. So if I'm given multiple answer choices, like this one could be A, and it could be 1 and 2. Well, this is a possibility because I have a total number of 12 units, and I know 2 times 1 is 2, so this could be a possibility of what she's modeling. But let's look at B. What if it was let's see, 4 as a denominator and 5 as a denominator. I have a denominator of 20, and we just can put a 1 for the numerator and a 2 for the numerator. So now I've got 2/20. Is this really a possibility? It's not, because there's not 20 squares. So of these answer choices, A would be the most reasonable because I'm looking at how many units total there are. All right? I hope that made sense. We we dealt with a problem like that in class, so I just wanted to kind of go over that with you again. But let's get back to multiplying two fractions together. So let's say Trevor is painting a mural on a wall. Okay, and he completed a rectangular part of the mural. So we know that we're dealing with a rectangular part of the mural. And a part of that mural is 3/4 meters wide. Well, I know it's going to be, this is the width, so it's going to be 3/4 here. And 2/5 meters long. How do I find the area? I multiply these two fractions together. So 2/5 times 3/4. I simply multiply across. 2 times 3 is 6. 5 times 4 is 20. And so 6/20 of the area is completed of the mural. Now, if you wanted to go a step further, you could totally simplify this by dividing by 2. 6 divided by 2 is 3, and 20 divided by 2 is 10. So we've got two answers that are acceptable, 3/10 or 6/20. We're not tested on simplifying, but so you don't have to, but if you want to go that extra step, you're more than welcome to. Both answers would be accepted. All right. And I'll do one more. Let's look at 7/10 times 3/2. So I'm going to do the same thing, but I realize that I have an improper fraction here, and that's okay. I'm still going to multiply. 7 times 3 is 21. 10 times 2 is 20. I want to see how many times 20 can go into 21. Well, obviously I know that's only going to be once, and I get 20. So one time, I have 1 left over with a denominator that stays the same, which gives me 20. All right? So I hope this helps. Bring in any questions that you would like. If you need extra practice, you can work through 8-2, 8-3, and 8-4 for extra practice problems in your Skinny workbook that you take home. And just let me know if you have any questions.